Hi and welcome to another short video from Koiro, and this time it is also about this, and this is my C64 power supply tester with a load circuit that actually puts the power supplies under load when we test them. And I actually made some mistakes when I designed this. I actually made one of the cardinal sins when making measuring equipment, and that is making the circuit affect the result. And as we saw in the last episode, the circuit here was totally blank when I measured with the power supply I got from Tommy and Arctic Retro. And he have clearly measured this power supply, and it gave it out AC voltage, and it also gave out an open pin voltage of 7 volts, but on this showed nothing. And that made me realize that I need to do some changes on this, and also my brother told me that I should power the voltmeters independently of the circuit. But that is a change I'm not doing. I'm going to make another change so that we will get some better results, even if the AC rail or the DC rail is dead. So that's what I'm going to do in this video. When we measured on this power supply, it was clear to me that we have to make an improvement over this, because when I measure the open voltages on this one, on the AC volt I actually get the right output, and I get about 10 volt. Yeah, 10 point something volt AC. And on the DC I actually measure something like 7 point something volt. That is the same that Tommy measured, 7.06 volt. But that's clearly not sustainable, so this 7 point something voltage drops to 0 and is not able to power this voltmeter. And here I made a slight mistake on this circuit, because this voltmeter for the AC line is also powered from the 5 volt rail here. But what I am going to do is I'm going to connect a diode here, so that either one of the voltmeters will be powered from either one of the power rails. But first I will start with this modification on this power rail, so that this will be powered off the AC rail if there is no power on the 5 volt DC rail. And if we look into the schematics here where we have this voltmeter here actually has a third connection that goes to plus 5 volt today. But that one I am going to change so that it is connected via a diode over here and to this voltage rail up here. And this is the rectified 9 volt AC line, and that will be suitable to connect this. And I will leave this connected to the plus 5 volt from actually all the way up here. And that is the way it is connected today. But that will be via a diode that is connected this way. So when I've done this modification, this AC voltmeter over here will actually power up and measure the AC line even though the DC line is not working. And I will also modify the 5 volt measurement rail here to be able to draw the power for the running of the voltmeter from the AC rail too. But first I'm gonna modify this one. And I'm going to use this standard 1N4001 diodes to make this modification. They will be more than big enough to supply this. I probably could have used the 4148 diodes just fine for this. If you listen carefully, you can hear the heavy rain on the roof of my shed. And this diode is going to be connected from this voltage here, like so, to this rail. Yeah, and I'm going to fast forward on the soldering job as I've explained everything in the schematics, and we are going to measure this out and explain this a bit further afterwards. Just going to give a short explanation of what we actually is doing here. And first I'm going to explain to those of you who does not have the in-depth knowledge of this what a diode actually is. And a diode is a one-way street for current, and that means that a diode only leads, it only transfers current from the positive to the negative when it's connected this way. If you turn this around, it will inhibit any current to flow in this circuit. So that means that a diode only makes it possible for current to flow from the positive to the negative. And that is what we are using in this circuit here. Because we actually have a 10-volt supply, that is the rectified AC line from the C64 power brick. That is one source of power. And the other source of power is the 5-volt rail from the C64 power brick. And what we're actually doing here is that we do a logical OR of these voltages. And that means that this voltage will flow from the positive to the negative. And if this voltage is present, then this actually has more positive power on this side than on this side. So this diode will not supply any voltage to the circuit. But if this is 0 volt, then this diode, or lower than 5 volt actually, this current will flow this way. So when this is present, the current will flow like this to supply voltage to the voltmeters. And if this is not present, the current will flow like this to supply. So we are doing a logical OR with the voltage, and the voltmeter power supply will be supplied anyway. And these voltmeters that we are using can take a supply voltage from anywhere from about 4 volt to about 20 volt something. So we will be well within specifications in this circuit. Yeah, and then we have to connect the power. This is the power that we know is have some defect, and we see that the AC rail lights up but not the 5-volt rail, and that is as suspected. Then this is working. The load will of course not work if the 5-volt supply is not working, but I will try now to modify this so that we can supply it in the same manner as this one. I will just disconnect it from the circuit and see what we can do with this. I will try with this meter that is actually already wired with 3 wires. And here I have wired up and soldered in the voltmeter, and I have connected this to the 5-volt rail for the measurement and to the common diode rail here for the supply voltage to the voltmeter. And on the schematics it will look something like this. I have connected now a power supply on the voltmeter, and this is connected to the common pin between the two cathodes on the diode OR circuit. But now just let us give this a test with the known failing C64 power supply and see how this actually works. And our new voltmeter is green, not blue as the first one, and you can see it steadies out on 0 volt. So it actually has the power supply, but it's not measuring the 7 volt that we had on the open pins on the power supply. And my trusty Metex tells us the same story. It's only 54 millivolts or something on this circuit. So I will then connect my trusty rebuilt C64 power supply with the green plug to see how that behaves after we have modified the circuit. So here you can see it shows up as 5.15 volt on the DC rail, and as we will see with the Metix now, this is well within our specifications and the use for this power supply tester. I will now try to show you how the defect power supply from Arctic Retro shows up when we measure without anything connected to the circuit. I will just add a connector here that makes it easier to measure. And here we can see the above 7 volt open circuit voltage that Tommy measured when he measured this power supply. And this is with no load whatsoever because a voltmeter has a very high impedance. But our circuit tester is drawing some power from the circuit, and that was enough to pull this to 0 volt. The AC voltage measures out about 10.9 volt something. Yeah, let's see this once more plugged into the tester. Here on our voltmeter, the AC voltage stands about 10.7, switching to 10.8, while the multimeter states that this is 10.9 voltage. That is well within what we need of accuracy on this. So this was the waste improvement of our tester, but as we can see, the load does not work when the 5 volt rail is not complete, and that might be good enough, but it's also possible to power the relay from the common junction point between the diodes. The relay will probably have quite a strong current when it's coupled to the 10 volt, but that is possible to find a solution for. The simple solution would be to use a 5-point-something Zener diode and a series resistor. Yeah, that's it about making the tester for the C64 Power Bricks. The next installment in this series will be to go in depth on the C64 Power Bricks and how they fail and what they do and how they look internally. And of course, as there is on all Commodore equipment, there is no standard that defines them all. And we have a lot of different schematics on the net, and we have a lot of different makes of the power bricks. Even though they look almost identical on the outside, there are a lot of different models out there that almost looks the same, but the inwards is slightly different. But the specification on them is almost the same all over the line, but they're not made the same. So in my next installment, I will go in depth of the power bricks and the internals of the power bricks. So hope you liked this video. Please hit like and subscribe. And it will really help out the channel if you hit like, even though you have seen this content on the net before. So until next time, thanks for watching.